Hello, and welcome back to TechFrame. What if cities could rise in days instead of decades? Bridges could defy gravity, and houses could stand firm against floods, earthquakes, and even fire. Around the globe, engineers are pushing the limits of possibility, creating construction methods that look more like wizardry than architecture. Today, we'll uncover 15 building techniques so daring and futuristic they will leave you questioning the very rules of construction. Floating staircase. Picture a staircase that seems to defy gravity, with each step jutting out as if suspended in mid-air. Floating staircases are designed with hidden structural supports, often anchored into walls or reinforced frames, creating the illusion that the stairs are weightless. Combined with glass railings or no railings at all, they give spaces a futuristic, open look, like something straight out of a sci-fi movie. More than just a design statement, they maximize space and light, making them popular in cutting-edge architecture and luxury interiors. Floating bridges. You've seen regular bridges made of steel and concrete, but what about one that literally floats? Countries like Norway and China have built floating bridges that rest on massive pontoons tethered to the seabed. Vehicles cruise across as if it's an ordinary road, but beneath them, the entire structure gently shifts with the waves. The level of balance required is staggering, yet these bridges hold up against storms and constant traffic. It's a construction method that looks impossible until you see trucks and buses driving across what looks like a road balancing on water. Top-down skyscraper construction. We're used to watching skyscrapers rise from the ground up, but in Tokyo and Singapore, engineers have flipped that idea, literally. Using a method called top-down construction, the upper floors are built first, suspended by giant supports, while the lower floors are dug and completed beneath them. Picture a building hanging in the air while workers carve out its basement. The benefit? Projects finish faster, and underground sections can be built, while the skyline already takes shape above. It's like watching a skyscraper grow in reverse. The moving building method. What do you do when a massive building is in the wrong place? In China, they don't demolish it, they move it. Engineers have transported entire multi-story buildings by putting them on rails or attaching hundreds of robotic legs that literally walk the structure to a new location. One school in Shanghai, weighing thousands of tons, was lifted and walked to a new site, shocking the world. Instead of rubble and waste, they preserve history with pure engineering genius. Underwater tunneling with immersed tubes. Imagine building a tunnel not by boring underground, but by sinking entire hollow tubes to the bottom of the sea. This method, called immersed tunneling, is how famous underwater highways like the Öresund link between Denmark and Sweden were built. Prefabricated tunnel sections are floated out, lowered into a dredged trench, and sealed together like giant Lego pieces. Engineers then cover them with gravel, creating a watertight passage. It's so precise that if one section is even slightly off, the whole tunnel leaks. Watching an underground highway come together piece by piece feels like seeing humans cheat the laws of physics. The slipform method. When you look at tall concrete towers, chimneys, silos, or even skyscraper cores, many are built using this slipform technique. This involves pouring wet concrete into a continuously rising mold, 24 hours a day, non-stop. Workers climb with the mold as it ascends, and by the time the process ends, an entire tower has been shaped in one seamless piece. No joints, no bricks, just one massive, unbroken column of strength. It's like watching concrete grow vertically in slow motion. Earthbag construction. Sometimes the most shocking construction methods are the simplest. In disaster-prone or rural areas, people use polypropylene bags filled with dirt, gravel, or sand to build homes. These earth bags are stacked like giant Lego blocks and plastered over to form walls strong enough to withstand earthquakes, floods, and even bullets. What's shocking is how cheap, durable, and eco-friendly this method is. Entire communities have been built using nothing but soil, sweat, and bags, yet they stand as strong as concrete. Prefabricated skyscrapers. What if a 57-story building could be assembled in just 19 days? That's what a Chinese company, Broad Group, accomplished by prefabricating steel modules in a factory and simply stacking them on site like Lego blocks. Each module already has wiring, plumbing, and interiors installed. On the construction site, cranes just lift and lock them into place. This factory-first approach means skyscrapers rise at lightning speed with astonishing precision. It feels less like construction and more like assembling a giant toy set, but one that can house thousands of people. The vacuum-powered bricklaying machine. Humans have laid bricks by hand for centuries, but in some countries, massive machines now use suction cups and robotic arms to lay entire walls at once. These vacuum-powered rigs can place thousands of bricks per day with perfect alignment, making them faster and more accurate than any mason alive. Watching the process looks like something out of a sci-fi movie. Giant machines slamming down perfect rows of bricks in seconds. For traditional bricklayers, it's both terrifying and awe-inspiring. Ice construction. Believe it or not, entire buildings can be made from frozen water. In places like Harbin, China, workers carve blocks of ice from rivers and stack them like stone to create towering castles, bridges, and cathedrals. But the shocking twist? Some engineers have experimented with mixing ice and wood pulp to create pykrete, a material so strong it was once considered for making warships during World War II. Ice as a construction material, it sounds ridiculous, but in practice, it's both dazzling and incredibly durable. At least until spring. Bamboo superstructures. In Hong Kong and parts of Southeast Asia, skyscrapers aren't always built with steel scaffolding. They use bamboo. Yes, the same plant used for chopsticks and garden fences can form massive construction platforms stretching hundreds of feet into the air. Workers climb barefoot across bending poles, tying them with simple knots, yet the structures hold steady under incredible weight. Bamboo is cheap, renewable, and shockingly strong. Stronger, in fact, than many forms of steel when it comes to flexibility. The hanging bridge method. Suspension bridges like the Golden Gate aren't built straight across. Instead, construction begins by shooting cables across the gap, sometimes with rockets or drones. Then, deck sections are suspended from the cables piece by piece until they meet in the middle. Watching workers dangle hundreds of feet in the air, assembling sections like puzzle pieces is nerve-wracking. The method looks impossible, but it's how humanity conquered rivers, bays, and canyons with some of the most iconic structures on Earth. Volcanic rock building. In parts of Italy and Iceland, builders have turned lava rock into entire villages. Volcanic stone is lightweight, strong, and naturally fireproof, making it perfect for construction. The shocking part is how it can be carved directly out of cooled lava flows, turning nature's destruction into shelter. From Roman aqueducts to modern eco-homes, volcanic rock has been used to shape architecture that literally rises from the ashes. The rotating tower concept. Picture this. You wake up in your bedroom and watch the sunrise over the ocean. A few hours later, without stepping outside, the same room slowly turned to face the skyline, giving you a view of the city's skyscrapers glittering in the afternoon sun. By evening, your dining table is pointed toward the mountains in the distance. That's not science fiction. It's the vision behind the rotating tower concept. Proposed by architect David Fisher in Dubai, the idea is to build a 1,300-foot skyscraper where every single floor can rotate independently. Think of it as a vertical stack of spinning discs, each apartment capable of turning 360 degrees. Residents could literally change their views depending on their mood. Breakfast with the sunrise, dinner with the sunset. What's even more shocking is that this design isn't just about luxury. It's also about sustainability. The building would incorporate wind turbines between each floor and solar panels across the roof and facades, generating its own power. In theory, the tower could produce more energy than it consumes. something almost unheard of in mega skyscrapers. Of course, the concept raises big challenges. The mechanics of keeping entire apartments rotating safely and silently are incredibly complex. Imagine plumbing, electricity, and internet cables that have to move with the floor without disconnecting, not to mention the staggering costs of building such a futuristic tower. Still, the rotating tower stands as a bold symbol of how far human imagination can push construction. If completed, it wouldn't just be a building, it would be a living, breathing machine constantly in motion, a piece of architecture that never stands still. The shifting sand method of desert architecture. When we think of deserts, we picture endless dunes, scorching heat, and lifeless wastelands. But to some architects, deserts aren't barren. They're full of raw building materials just waiting to be unlocked. The shifting sand method is a groundbreaking construction approach that aims to turn the desert itself into the bricks, glass, and structures of the future. Here's how it works. Desert sand, when heated to extreme temperatures, can actually fuse into a glass-like material. Engineers have begun experimenting with solar-powered sand printers, giant lenses that concentrate sunlight onto sand, melting it into bricks and tiles. Instead of shipping concrete or steel into remote desert areas, builders could create materials on site, using nothing but sand and the sun. It's construction alchemy, turning dunes into durable structures.